Hello students, welcome to YouTube channel of Akshar Education. In this video we are going to discuss proof of theorem number 10.2. Here theorem 10.2 says that the length of tangents drawn from the exterior point to a circle is equal. The length of tangent drawn from the exterior point to the circle are equal. Length are equal. So what we are given? So let us consider one diagram. One circle is given, circle with center O. Then you have to consider the length of tangent drawn from the exterior point to a circle. So let point P, which is a point in the exterior of circle. So we have to draw the tangent. We know that we can draw two tangents from a point which is exterior to the circle. So maximum we can draw two tangents from the exterior point. So two tangents are tangents PQ and tangent PR. So length of tangents, so this length drawn from the exterior point to a circle are equal. So we have to prove here given. First we write down the given. What we are given? Circle with center O and point P is in the exterior of circle. This is given, and PQ and PR are the tangents. PQ and PR are tangents drawn through it. One circle with center O is given, one point P in the exterior of circle is given, and two tangents from the point exterior to the circle are given. Two tangents are tangent PQ and tangent PR. This is given. Circle with center O, one point P in the exterior of circle, and two tangents drawn from the exterior to the circle are given. We know that we can draw maximum two tangents from the point which lies in the exterior of circle. Done. So two tangents are there. So according to this theorem, if we draw two tangents to this circle from the exterior point, the length of these two tangents are equal. To prove, we have to prove that length of these two tangents are equal. So length of these two tangents are PQ and PR. PQ is equal to PR. This we have to prove. Done. So now proof. For the proof of this theorem, first we will join this point, exterior point, to the center. Join P with O. Join P with O. Join OP. Join OP, that means P with O, and also join OQ and OR. So join OP, OQ and OR. Done. Hence we are getting two triangles, or you can say two right angle triangles, triangle OQP and triangle ORP, because this OQ is the radius. So according to theorem number 10.1, tangent is perpendicular to the radius through the point of contact, so it will be 90 degree. Done. So now here we can say this OQ is perpendicular to PQ and OR is perpendicular to PR. Reason? According to theorem number 10.1. Theorem 10.1 says that tangent is perpendicular to the radius through the point of contact. PQ is the tangent, Q is the point of contact, and OQ is the radius drawn through this point of contact. So this radius and this tangent are perpendicular to each other, so this angle will be 90 degree. Same way, this PR is the tangent, OR is the radius drawn through this point of contact, so this radius OR will be perpendicular to this tangent PR, so angle ORP is the right angle. So we can say that these two triangles are right angle triangles. So now we will consider two triangles. So in triangles OQP, in triangles OQP and triangle ORP, consider the correspondence between these two triangles ORP, one-to-one correspondence between these two triangles. So here we can see that right angles OQP and ORP are congruent. So angle OQP equal to angle ORP, right angles, according to this theorem number 10.1, right angle. And here OP is the hypotenuse for this right angle triangle OQP, as well as OP is the hypotenuse for the right angle triangle ORP. So OP is the hypotenuse which is common between these two triangles. So OP equal to OP, which is common side, which is nothing but the hypotenuse of the both of the right angle triangle. RH. Now S, side. Consider these two sides OQ and OR are equal. This OQ and OR are equal. OQ and OR are equal. What is the reason? OQ and OR are nothing but the radii of same circle. So here, according to right angle, hypotenuse, side, RHS rule, these given two triangles are congruent triangles. Triangle OQP is congruent to triangle ORP by RHS rule. Triangle OQP is congruent to triangle ORP, and therefore we can say that its corresponding parts are equal. Corresponding parts are PQ and PR. This PQ and PR both are equal by CPCT. By CPCT, corresponding parts of congruent triangles are equal. If two triangles are congruent triangle, their corresponding parts are equal. So PQ is equal to PR. So PQ is nothing but the length of tangent drawn from this point P to point of contact Q, and PR is nothing but the length of tangent drawn from the exterior point P to the point of contact R. So length of tangents drawn from the exterior point of the circle are equal. Clear, students? So this is how you can prove your theorem number 10.2. Pause the video and okay, students, one more important point from this theorem number 10.2. Instead of this theorem 10.2, we may also ask to prove one statement. So that statement is, here this property we will use in our all the numericals. Here we may ask to prove that center of circle, center of circle lies on this is center of circle lies on bisector of angle between two tangents, angle between two tangents. We know that for any circle we can draw maximum two tangents from the exterior point. So if we draw two tangents from this exterior point P to this circle with center O, so we are getting one angle P, angle QPR, and here the bisector of this angle is PO, and that bisector will pass from this center. So center of the circle lies on this bisector. So here we have to prove that OP is the bisector of this angle formed by these two tangents PQ and PR. So we have to prove these two angles are equal. Then we can say this OP is the bisector and center lies on the bisector of the angle formed by these two tangents. So from here, from these two results, these two triangles OQP and ORP are congruent triangles. So here we can add one more result, that is angle QPO. Angle QPO is equal to angle RPO by CPCT. Done. These two triangles are congruent triangles, so corresponding parts are equal. So these two corresponding angles are equal from this result, and hence we can say that OP, or you can say PO, is the bisector of line PO is bisector of angle QPR. Bisector of angle QPR. What is angle QPR? Angle QPR is the angle between two tangents. Angle between these two tangents. Angle between these two tangents PQ and PR is angle QPR. And for this angle QPR, PO is the bisector. PO is the bisector. Bisector passes through the center. Bisector passes through the center, and that's why we can say that the center of circle lies on the bisector of the angle between tangents PQ and PR. That we have to prove. Clear? Center of the circle. What you have to prove? Center of the circle lies on the bisector of angle between two tangents. Done? Two tangents are PQ and PR. These two angles are congruent angles by this theorem, and therefore we can say that PO is the bisector passing through the center, and hence we can say that this center lies on the bisector of the angle between which two arms? Between these two tangents. Clear, students? Again pause the video and note it down.